In today's video, we're going to take a look at some cofunctions. All right, so we're going to take a look at some trig relationships. And the relationship we're going to look at in terms of those trig ratios are going to be the sine and the cosine. All right, so we're gonna do a little discovery exercise for number one. So I kind of like that. That's kind of cool. That's where we should be headed. All right, so let's dive right in here. So it says write expressions for the sine and cosine of angle A. All right, so some strategies that we're going to follow through on. We're going to highlight the angle. All right, and we're gonna mark up our triangle. So the side opposite angle A is going to be O. Okay, the side opposite our right angle is going to be our hypotenuse. And the side right next to angle A is going to be our adjacent. All right, before we even start, we're going to put up top the sine equals the opposite over the hypotenuse. The cosine equals the adjacent over the hypotenuse. And then the tangent equals the opposite over adjacent. All right, so A says write expressions for sine and cosine of angle A. So I'm going to write sine A equals my opposite, which is A, over my hypotenuse, which is C. And the cosine of A, it's going to equal my adjacent, which is B, over my hypotenuse, which is C. B says now write expressions for the sine and cosine of angle B. So what I'm going to do is I'm going to erase, except for my hypotenuse. That stays the same. And then I'm going to highlight angle B. Side opposite, as I mark my triangle. And the side next to it is going to be my adjacent. So the sine of B equals my opposite, which is B, over my hypotenuse, which is C. The cosine of B equals the adjacent side, which is A, over the hypotenuse, which is C. Now C says, do you notice a relationship between any of the trig ratios written above? So why don't you pause the video, take a look, and see if you can notice a relationship on our trig functions that we wrote down. All right, so what I came up with is that the sine of A, if we see that, the sine of A equals the cosine of B. And the cosine of A equals the sine of B. And there's a reason that this happens is that in any right triangle, any of the two acute angles, we know that our angles that are not right, which are the other two, have to be acute angles. Well, they're complementary. They're complementary to each other because we know that the sum of our triangle has got to equal 180 degrees. So the sine of an acute angle is equal to the cosine of its complement, as well as the cosine of an acute angle is equal to the sine of its complement. And we know that complements are two angles that are added up to equal 90 degrees. All right. So example 1 says, find the value of theta for which the statement sine theta equals cosine 15 degrees is true. So how would we make that true? Well, if I have two angles or two complementary angles, we know they have to add up to 90 degrees. And those are the two complementary angles. So theta plus 15 degrees will add up to 90 degrees. So theta, which is the complement of 15, equals 75 degrees. So my answer is sine 75 degrees, because the sine of 75 degrees equals the cosine of 15 degrees. Now, a really good experiment is to stop here, take your calculator, and find the sine of 75 degrees. Get that number, and then find the cosine of 15 degrees and get that number. Those two numbers should be equal, or they will be equal. All right, example 2. It says sine 42 degrees equals, well, the cosine of 48 degrees. And then the cosine of 12 degrees equals, well, the sine of 78 degrees. How do I know? Because they're complementary. And then the sine of 45 degrees has got to equal the cosine of 45 degrees. Now, a cool thing is that we can solve for the unknown. Back to the algebra. So I have the sine of 3/4 x equals the cosine of 1/4 x. So I can find x. I can set up an equation. I know that the two angles, that sine and cosine, are complementary. So my equation is going to be 3/4 x plus 1/4 x equals 90. Remember that definition of complementary? Two angles added up to equal 90 degrees. So if I add those two, if I add 3/4 plus 1/4, we know that's 1, or x equals 90. E says the sine of 5x minus 22 degrees equals the cosine of x minus 10 degrees. Well, same setup, because we know those two angles added together equal 90 degrees. So I'm going to have 5x minus 22 plus x minus 10 equals 90. I'm going to combine my like terms. So my 5x and 6x, 5x and x is 6x. And then negative 22 minus 10 is going to be minus 32. That's going to equal 90. I'm going to add 32 to both sides of the equation, and I'm going to get 6x equals 122. When I divide 6 to both sides, I get x equals 20.3. My last example is that the sine of 3/4 x minus 3 equals the cosine of 66. Well, again, I'm going to set up my equation, 3/4 x minus 3 plus 66 equals 90. I'm going to do a little cleanup. I'm going to get 3/4 x plus 63 equals 90. I'm going to subtract 63 to both sides, and I'm going to get 3/4 x equals 27. Okay, so what I'm going to do is I'm going to multiply by the reciprocal. Remember that? So that's going to be times 4/3 times 4/3, and x is going to equal 36. All right, so what I want you to do, very important, just like always, I want you to write down the key ideas. Again, I will check that, and we will go over that tomorrow in class. I also want you to use your notes to do your check for understanding, or check your understanding. Some very important information here. You should definitely have a couple key ideas down in this lesson. And remember, go Cats, go Knights.